Okay, this is the truss. As you can see, it has a distributed load and a point load. Trusses usually don't have distributed load. I just did it here so to let you know that you can do that if you want to. It's at a height of 10 feet in the span of 30 feet. I'm gonna label it using finite element method or way of labeling. As you can see, it has a pen here and a pen here. The structure is statically indeterminate. Now what we can do is we start labeling using finite elements method. This is node 1, node 2, node 3, node 4, node 5. This is element 1, element 2, element 3, 4, 5, 6, and 7. So we have 7 elements. Okay, let's go to the website. Okay, let's visit structure analysis. You can minimize the menu if you want to have more spaces. So we need 7 elements. Get you started with 1 element, but you can always generate more here. It generates 7 elements. As you can see, it starts from element ID 1 to element ID 7. So we can always refer back to the truss sketch to see how we input the data. So nodes are usually start at 0, 0 from the origin. That's why I like to draw them starting from the origin. So first node is gonna be 0, 0 and ends at 15, 0. It has a pen support at the start at 0, 0. And doesn't have any load, so you can just move on to the next element. Element number 2, it starts where this one finished, so it's gonna be 15, 0 and ends at 30, 0. And it has a support at the end, it means at 30, 0. It has a pen as well. It has no load, so we move on to the next element. Okay, so now we enter these elements and this supports, this element and this support, which means node 1, 2, and 3. Okay, so node element number 3, it's this one. So it starts at 0, 0 and ends at 10, 10, 10. Okay? As you can see, this is 15, 15. This is 10. So this one is going to be right here. As you can see, it's 120 inches, but I'm doing it in feet. You can use any unit you want. I'm just using US customary. It could be meters, could be centimeters, whatever you want to use, and the load as well. This is, I'm just putting here 10 pounds. It's a small amount. You can think of it as 10 kips. This is 10 kip per foot or kilonewton per meter. It doesn't matter. Or this 1 kilonewtons. Think of it as a truck load or something. Okay. So let's go back. Element number 3 starts at 0, 0 and end at 10, 10. It has no support, no load. Because we can technically use this one as support and don't use that one. But since we already used the support, we don't have to use support here. Okay. Now we move on to this node right here. Starts at 10, 10. Then ends at 15, 0. Element number 4 starts at 10, 10 and ends at 15, 0. It has no support, no load as well. Element number 5 So this one starts at 15, 0 and add at 20, 10. So 15, 0, 20, 10. It has no support or load. Okay, element number 6, this one, starts at 20, 10 and ends at 30, 0. Starts at 20, 10, ends at 30, 0. Also, it doesn't have load or support. Last element is element 7, starts at 10, 10, ends at 20, 10. And it'll be 10, 10, ends at 20, 10. Okay. And it has a distributed load of 10. You can leave the load after you're done and you can add it. Like here, adding here 10, I'm gonna look for the point load. Point load, you have multiple options where you can enter it. It doesn't matter. What's really matters is this node has to be defined before you add the load to it. So you can just go, for example, we can define it on the first element. So you can see the first element, or any element that has this node defined. Okay, so we can here put if y maybe -10, and it's acting on distance of 15 from the origin. Okay, hopefully I entered everything correctly. Double check if you have to, and then run the analysis. As you can see, this reflects the sketch that we have. You can see we have a distributed load of 10, point load on this node of 10, pointing down, and we have a 2 pin supports on each end. So you can see here are the numerical values. There are shear force, moments, and axial load. The reason I include these numerical values is because if you can't read them from the graphs that generated, such as reactions, such as the shear diagrams and moment diagrams or the axial diagrams. Here are the reactions. Shear diagram. Let me pause a little bit here so you can see this overlapping. Sometimes it's hard to read them. Here's the bending moment diagram. Here's the axial diagram, which is the most important graph, I think, when it comes to trusses. The shaded orange are basically in compression, shaded blue are in tension. Okay. All right. You can here you can see exactly in detail how it. See, this is the origin 0, 0. You can see this is the origin. This is how we draw it, and you can see this is node 1, node 2, node 3, node 4, node 5. Then the elements are labeled in red. So element number 1, element number 2, number 3, 4, 5, 6, and 7. Okay. Alright. I think that summarized this structure analysis. I did 2 examples, just to recap. I did a beam example and a truss example. Hopefully these 2 examples will make you understand how to use the form Hopefully these examples will get you started on start using Structure Studio. Thank you for watching, and I'll see you in the next examples.